13.5 is the last section we're going to learn of the year. So we're going to learn it in 3 different parts, maybe 4 if we need to slow it down a little bit based on how you're picking up on it as we go. So far, we have been taking integrals that were called indefinite integrals because you had plus c at the end, and sometimes you solve for plus c. But now we're going to do what are called definite integrals, and that's where we are going to have limits of our integral. So we're only finding the integral within a certain interval. So if you remember, an integral is the area under a curve. So far we have just been finding the equation to help you find the area, but now that we're setting limits to our integral, we're going to find the actual area between those 2 points. So if I were to graph this, because this one's an easy one to graph, this example here, 2x looks something like this. And so I'm literally finding the area under this line between 2 and 3. So like here's 1, 2, 3. I'm literally finding this area right here. And I'm not drawing rectangles anymore because I'm taking the integral. I don't have to estimate anymore. I'm finding that actual area. And so if I didn't have those limits there, I would just be finding the equation and then I'd have to plug in numbers based after the fact. So now I'm going to actually be finding the areas and my answer is going to be a number. And so the rule for calculating this is if I've got f of x right here, I can take the integral. Let's think about the notation is the integral of f of x is capital F of x. That means the integral of it. And so what I'm going to do is I'm going to take the integral of f of x and I'm going to do f of b minus f of a. So I'm going to plug in b and I'm going to plug in a and then subtract them. So let's do this example here. The integral of 2x is 2x squared over 2, which is just x squared. Now instead of putting plus c, I am going to evaluate it from 2 to 3. So I'm going to do 3 squared minus 2 squared, which is 9 minus 4, which equals 5. So the integral from 2 to 3 of 2x is 5. And so that means this area is 5 right here. Let's take a look at some more examples. The next one is the integral of 4 from 0 to 10. So we know that the integral of 4 is just 4x. We're going to evaluate it from 0 to 10. So notice how definite integrals no longer have plus c. You only need plus c for an indefinite integral. So indefinite means there's no limits on your integrand. And so that means I have 4 times 10 minus 4 times 0, which is 40. And that's your final answer. Let's take a look at the next one. The integral of x cubed is x to the 4th over 4. I'm going to evaluate that from 0 to 4. So I have 4 to the 4th over 4 minus 0 to the 4th over 4. 4 to the 4th over 4 is the same, is going to be 64 when you type it in the calculator, minus 0, which equals 64. And that's your final answer. So let's look at the next one. The integral of e to the x is e to the x from 0 to 1. So I have e to the 1 minus e to the 0. I'm going to leave e to the 1 as just e to the 1. e to the 0 is 1. Anything to the 0 power is 1. So I'm going to leave my answer like that. You can also type this into the calculator to get a decimal, and so Math Excel will tell you if they want it left like this or in a decimal. So if I type this in, e to the 1 minus 1, I get 1.718. So just know that you can type these in the calculator and get a decimal too. Let's look at this next example here. 2 over x. So the integral of 2 over x, I can take out the 2. So now I just have the integral of 1 over x. So I know that the integral of 1 over x is natural log. So I have 2 natural log x from 1 to 5. So I have 2 natural log 5 minus 2 natural log 1. Well, the natural log of 1 is 0, so I'm just left with 2 natural log 5 minus 0, which is 2 natural log of 5. You can leave it like that, or you can type it in the calculator and get 3.22. Those are your options. I'm going to do 2 more examples here, and then we'll pick up more on this on Thursday. So we've got the integral from -2 to 2 of x cubed plus 7x. So I'm going to take the integral of this. So that becomes x to the 4th over 4 plus 7x squared over 2. And I'm going to evaluate that from -2 to 2. So I've got 2 to the 4th over 4 plus 7 times 2 squared over 2 minus -2 to the 4th over 4 plus 7 times -2 squared over 2. So in the first fraction, I end up with 16 over 4, which is 4, plus 28 over 2, which is 14. And then I also have 4 plus 14 over there. So I have 18 minus 18, which is 0. Make sure when you're plugging in negatives, you put them in parentheses so that you don't mess up their negatives. And the last example we're going to do today is 6x minus 5. The integral of 6x minus 5 is 6x squared over 2 minus 5x. And I'm just going to simplify that a little bit. 3x squared minus 5x. I'm going to evaluate that from 1 to 4. So I've got 3 times 4 squared minus 5 times 4 minus 3 times 1 squared minus 5 times 1. So in the first one I have 16 times 3, which is 48, minus 20. And the second one I have 3 minus 5. So I have 28 minus a -2, which is 30. You've got some practice problems that you can do for homework, and we will continue this lesson on Thursday.